Hello everyone, this is Cameron Snow with Danomics.com. In this video, I'm going to be showing you the workflow for assigning a projection to a folder. Then we are going to use a flow to process our deviations to go from measured depth, inclination, and azimuth to a TVD and XY offset. And then we're going to use those to make a 3D display. So let's get started. Over here in my project window, you'll notice I have created a folder and I've loaded some data into this folder. With respect to what I loaded, we have just a basic log database file, tops file, and some well headers. I did load these well headers in XY coordinates. However, you can load those in either XY or lat long. You'll also see that I've loaded up some deviation surveys. Remember, when loading deviation surveys, these just come in as a points file, and you'll need to have 4 columns on those. The first is the API number. The second is measured depth, then inclination and azimuth. These columns can be, with respect to measured depth, inclination, and azimuth, these columns can be in any order, but it is important to have the API number in the first column. You can load multiple wells into the platform at one time. So you can see here that we do have several wells with deviations in this file. So the first thing you'll want to do is you'll want to process those deviations into the correct format for display. So to do this, we'll create a flow. If you don't have a flow that already does this, you can right click and say new flow, and this will create one in the folder. But we already have one here. And this flow has 3 blocks in it. The first is a points input, and in this, all you'll do is you will select that points file. So this file here, we just select. Then we'll have one called deviations to XYZ, and here you'll just match the columns up. So API to API, measured depth to measured depth, inclination to inclination, and azimuth to azimuth. And the data will come out of this deviations to XYZ block in a points output. And so here we'll just give it a name, and in this I'm just going to call it process deviations. And it will write this file to the folder that the flow is inside. So we'll just hit the play button here. And as we do this, this will pop up a jobs menu, and that will process asynchronously. So while that is processing, and that'll only take a few seconds, let's go ahead and add a projection file to our folder. So this is a new feature where we have the project level projections. So it's probably new to most of you. So the way we'll do this, we'll right click, and you will now see an option here for edit projection. So click on edit projection, and it asks you if you would like to create a new projection file in the in this folder. So I'm going to hit OK here. And right now it says our data projection is in lat long. That's the default that everything comes into. So we are going to select to use a projection file. We're going to choose this file, and I'm just going to grab one here off my desktop. And so we can see it basically gives us the well-known text for this. So it tells us this is a Wyoming file, which is correct because I'm working in a Powder River Basin project. And once I've done that, I just need to save. So File. So we can either go File, Save, or we can hit Control S. In the meantime, our deviations have now processed. And we'll now see this new points file called process deviations that we wrote out of our flow. And so now we can see that we have our API and our measured depth, as well as TVD, a DX, and a DY, and also a consistently named inclination and azimuth. So now we would like to use these deviations. There's a couple of different ways that we can do that. So I'm going to close these flows. The first thing I'm going to do is I'm going to create a new petrophysical calculation. And I'm just going to call this 3D demo. And you'll have noticed in our last release, in the setup menu, we have some new options. First of all, I just need to choose these databases. So I'm going to select those databases, and I'll go ahead and select a key well, because remember, we want to perform operations on our key well. And so now we have specified a well as our key well, and that's what's being displayed. And now you'll notice we have here in the setup, we have this deviation survey points, and also we have a deviations module here. And if we and we'll now have the option to select those process deviation points. So if we select those, now we have loaded in the deviations into our CPI file. And so now when we're doing things like pressure calculations or looking at wellbore stability in our geomechanics module, it will use the deviation information as part of that calculation. So that's one way in which you can use the deviation surveys. The second way is by displaying them in a map or in 3D view. And so once again, I'm going to right click here and I'm going to say new map. And once again, we'll just give that a name. So I'm just going to call it 3D demo again. Okay, and now you'll see there's not only a map tab here, but there's also a 3D view tab. So we're going to start off by populating our map. And I'm just going to choose my well markers for this, and I'm going to choose the ones that I just loaded. We're going to add those in, and now we see that they appear here in the Powder River Basin, which is where we wanted those to appear. And we can see that we have a number of deviated well bores here. So I would like to see these in 3D so I can get a better understanding for those well bores, make sure that our surveys have loaded properly. So what I'm going to do is I'm going to split this window so we can look at both the 2D view and the 3D view at the same time. So I'm just going to grab this tab and move it over. And now we'll need to add a couple of layers here. So the first thing we're going to add are just well markers, and this will display the surface location in 3D. And so I'm going to hit add there. And now we can see that we have the well headers that have shown up. I'm going to add another layer, and for this one I'm going to add a well bore. And now we'll need to select two data types. We'll need to select our well headers again, and we'll also need to select our process deviations file. Now it's important that you select the process deviations, as that contains the information needed to display the well bore in 3D. And then we'll hit add, and I'm going to get this menu out of the way. And what I want you to notice is that here you'll see there is a center and a camera, and as I navigate in here, we can zoom in, we can zoom out, and we can rotate around this around and manipulate it. And here we can see some of those deviated wells. So here we can see well bores drilled off a couple of pads here. We can see we have a few longer wells here where we have some short deviations. We also have some wells that were these 10,000 foot and longer laterals. And so I can use this as a method to QC some of these projections and look to make sure there's nothing that looks abnormal in here that we may need to go do some cleanup on. All right, so in this video, we've gone over a few different things. So remember, first of all, we just loaded our data as normal. The only extra piece of data we loaded was a spreadsheet that had the measured depth, inclination, azimuth, and API number that we loaded as a points file. We then built a flow, and that flow had three blocks: a points input, deviations to XYZ, and points output. We then added a projection to our folder, and we did this by using a right-click, edit projection, and where we selected the .prj file, and we were able to QC that by looking at the well-known text associated with it. And then we finally created a CPI file where we were able to load in our deviation surveys using the new deviations module, and we were able to make a map with an associated 3D display. All right, I hope this is useful to you, and we're going to be adding a lot of extra functionality around 3D displays to give you the tools that you need to to really start understanding the spatial relationships around your data, giving you some more mapping tools and some more geoscience tools in the package. If you have any questions about how to use this, please contact us. You can reach us anytime at support@danomics.com. Thank you.